Final lesson for Chapter 9 is going to give us some more ways to analyze data distributions. Okay, so recall that in statistical displays, peaks, gaps, clusters, and outliers are identified easily. We've worked with that with scatter plots. So complete the graphic organizer by matching the terms with the correct description. So we've got a gap, a peak, an outlier, and a cluster. So something where there are no data values, well, that's probably a gap. The most frequently occurring value or the interval of values, that'd be a cluster. Most frequent, nope, that would not be, because this one was better. When many data values are grouped together would be a cluster. The most frequently occurring value or interval, that's a peak. And an outlier is the last one, a data value that is 1.5 times the interquartile range from the first or third quartile, so a lot farther away. So those are some good vocab repeaters. So I told you before that I would tell you how to find outliers, and I'm going to go ahead and do that. So to find an outlier, it says a data value that is 1.5 times the interquartile range, which a lot of times it gets abbreviated to IQR, from the first or the third quartiles. So that means we need to know what the interquartile range. So here's an example. The minimum, quartile 1, median, quartile 3, and the max. To find the interquartile range, that's your third quartile minus your first quartile. So if I plug those in, 31 minus 17, I get 14. So an outlier has to be 1.5 times the interquartile range. So I'm going to write it like this. Outliers are 1.5 times the interquartile range above or below. So I need to do 1.5 times my interquartile range of 14. That gives me 21. So anything that is below 21 below the quartile 1, so quartile 1 was 17, so 21 below it would be -3. So anything below -3 or 21 points above the third quartile, 21 equals 52. So anything below -3 or above 52 would be an outlier. So outliers would be less than -3 or greater than 52, using some abbreviations there. So then if we move on to slide 3, we have some vocab words there. The distribution, that's just going to talk about the shape. The distribution of a set of data shows the arrangement of data values. So this is just going to talk about the shape. So distribution is just the shape of the data. It can be described by its center, which is the mean or the median, how spread out it is, and its overall shape. Determining the symmetry of the distribution is one way to describe shape. If the left side of the distribution looks like the right side, then the distribution is symmetric. So this one looks symmetric because it looks pretty, it's perfect. Left side looks like the right side. This one doesn't look exactly the same, so that would be a non-symmetric data. Another way to describe the shape of distribution is to identify peaks, clusters, gaps, and outliers. If there's an outlier, the distribution is not symmetric. So I'm just going to underline this. Always. If the distribution has an outlier, it will never be symmetric. And remember, to be symmetric, it has to look the exact same. And peaks and clusters have to be really obvious. Like obviously the biggest thing, or obviously a bunch of things grouped together. Okay. So on slide 1, we have to talk about the graph shows the weights of adult cats. Identify any symmetry, clusters, gaps, peaks, or outliers. So the distribution, that would be the symmetry. Non-symmetric or symmetric. This one is non-symmetric. Clusters, you might say that this is a cluster. You might say maybe there is none at all because it's all kind of pretty spread out. But I'm going to go ahead and say that there's a cluster of cats that weigh 7 to 12 pounds. Yeah, pounds. Gaps at 13. Peaks, the highest, the most occurring weight was 10 pounds. That occurred 3 times for these cats. Outliers, nothing is so far off from here that there wouldn't be an outlier. So we're good to go there. Outliers are usually pretty obvious, but sometimes not. So on slide 5, identify any symmetry, clusters, gaps, peaks, or outliers here. Well, this one might be an outlier. We're going to have to use our math to check that. So the distribution, symmetric or non, this would be non-symmetric. Where is most of the data put together or clustered together from 60 to 63 inches. There's a gap at 59 and from 64 to 70. And then we have, where is the most occurring height is at 61 inches. And an outlier is probably 70, but just in case we don't know for sure, we can do that interquartile range thing, which means that we're going to have to find the median and define the upper and lower quartile. So I'm going to try and be really careful here and just find the median. Instead of rewriting this out as a whole list, which hopefully I won't have to do, I will find the median this way. By crossing them out and finding which one is in the middle. 61 is in the middle, 261. So the median is 61. And then I got to split that and find the lower and upper half. So I'm going to use a different color here. So cross out, cross out, cross, 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 cross. I've got 2 in the 60s, so that would add together would give me and divided by 2 would give me 60. Q3. So I'm going to use another color because that kind of got messed up. Let's cross that one out and this one out. This one and this one. This one and this one. So I'm left with 62 and 63. So the number between 62 and 63 is 62.5. So to find the interquartile range, we need to subtract those quartiles. So Q3 minus Q1, 62.5 minus 60 gives me 2.5. Remember that the outliers occur at 1.5 times that. So outliers would be 1.5 times the interquartile range, which ends up being 3.75. So anything above the third quartile, 3.75. So Q1, anything below 60 is 60. So 60 minus 3.75 would give me 56.25. Nothing happens below there. Q3, anything above 3.75 above 60. So anything above 63.75, which that one does, is an outlier. Not hard work, just a lot of it. Okay, slide 6, some more information here. Describing the center and spread of a distribution. The shape of a distribution tells which measures are most appropriate for describing the center and spread of distribution. So the mean and median, or the mean and the mean absolute deviation, are affected by outliers, while the median and the interquartile range are resistant to outliers because they're just the middle numbers. Use the following graphic organizer to decide which measures of center and spread are most appropriate to describe a data distribution. So if it is symmetric, we're going to use the mean absolute deviation, which this one, okay, and this one, if there are any outliers, we're going to use the interquartile range and the median. So median and interquartile range, mean and mean absolute deviation. Okay, so we have to decide which one is our more appropriate. So the number of nachos sold at a football concession stand is shown on the line plot to the right. Describe the center and spread of a distribution. Justify your response based on the shape. So what would describe the center? Is this symmetric or not? So this is non-symmetric. So if you look up at that table or that graphic organizer, slide 6, not symmetric, no. So we're going to use the mean and the mean no. Is the distribution symmetric? No. Use the median and the interquartile range. So we use the median and the interquartile range. Because why would we use this? Because it's non-symmetric. And we have to find the median then. So if we find the median, we will cross out our x's. I'm going to go 2 at a time. And we get 25 nachos on average. The spread of the data, the interquartile range. So I need to find Q3 minus Q1. So that means I have to find the medians of these other things. So lower half, 1, 2, 1, 2, 1, 1, 1, 1. Be stuck at 24 for my first quartile. My third quartile, 1, 2, 3, 1, 2, 3, 1. Going to be stuck at 27. So 3 nacho bowls. So I can plan for the average of 25, but I should have up to 28 on hand. Okay. One more where we describe the best way to describe the average. So the graph shows the hours per week that the dance students practice their dances. Describe the center as spread. Justify your response based on the shape. Round to the nearest tenth. So what describes this better? So if we look up here, is the distribution symmetric? Yes. So yes, we need to use the mean. Why? This is symmetric data. And the mean absolute deviation go together. So to find the mean, what's nice about the mean when things are symmetric, it's always going to be the middle. So because it's symmetric, it's going to be 5 hours. And then I'm just going to say because it's symmetric, it's the middle data point. So that's a nice little trick. We could also add all these up. We do 1, 2, 2 3s, 3 4s, 4 5s, 5 6s, that kind of thing. So then to find the mean absolute deviation, we have to figure out how far each one of these is away from 5. So 2 is 3 away from 5. And there's 3 is 2 away, but there's 2 of those. So 3 plus 2 plus 2. 4 is, there's 3 of those, and those are all 1 away. 1, 1, 1. Plus, there's going to be 5 zeros. So 0 plus 0 plus 0 plus 0 plus 0. Would you have to include that? No, but just keep that in mind, that don't forget to count all your numbers to find the mean absolute deviation. And now the left side looks the same as the right since it's symmetric, so I can just copy this. And then I'm going to divide by how many there are. There are 1, 2, 3, 4, 5, 6, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So I divide by 17. So if I add all those up, I get 20. 20 divided by 17 is 1.2 hours. Average student studies for 5 hours, or the student studies for an average of 5 hours, but some might go as low as 3.8, some might go as high as 6.2. Fun fact, George Washington's face is 60 feet long on Mount Rushmore. Have a great day.